Good morning, and as always, slow is smooth and smooth is fast. So what I'm going to talk through today is this idea of where we're going with this chemical and physical change thing. So the first thing I want you to do is write your own definition of chemical and physical changes. We talked about this yesterday. Take a moment, pause this video, write your definition of chemical and physical changes. It should have related this idea that this changes the material. This changes the appearance of the material. It doesn't necessarily change what it is, but it changes how it looks. So this changes the chemical formulas, changes just how it looks. This is state, crumpling. This is happening at an elemental level. So what this will lead into is the next step we're going to take is this idea of what a chemical change is and for why a chemical change happens. So if I have a paper plus oxygen, that's not going to have a chemical reaction. There's not going to be a chemical change. There won't be a chemical change because there's nothing that starts the reaction. There needs to be a driving force. And in this case, I used fire. Once I had that driving force, was produced ash and oxygen. Sorry, CO2, carbon dioxide. I produced those two things in that reaction because I had that driving force. From there, so this reaction is called a combustion reaction, because there's burning. So a combustion reaction is when you take a carbon compound and a hydrogen compound, react it with oxygen to form carbon dioxide plus water. Water is always a product of a combustion reaction, which is why your tailpipe will leak water even if your AC is not running, because water is a product of a combustion reaction. Some other examples of combustion reactions are when you put things together. So synthesis, A plus B goes to form AB. So I have two things together. So two things together separately become two things together. A decomposition reaction is taking A, B, goes to form A plus B. This is the opposite of a synthesis reaction where you're taking two things and you're breaking them apart. The two other types of reactions that we're going to look at is a single replacement reaction, which is kind of like high school dating. If you take A and B are together and you have a third party, A stops dating B, starts dating C, and B is left all alone. A better, happier arrangement for everyone is a double replacement reaction, where A and B are dating, C and D are dating, and they switch who's dating who. So A is now dating D, plus C is now dating B. These are the 5 basic types of chemical reactions. They all take a driving force, a start of the reaction. We will look at the start of the reaction more as we go. Sometimes it's called an activation energy. We will look at this idea more as we go. A chemical reaction has two main parts. It has reactants that go to form products. Reactants equal products. They have to have the same because matter cannot be created or destroyed. So our reactants are going to be equal to our products, but only changed. At the end of these notes, I want you to take a moment and I want you to write out how the 3 labs from Monday were chemical reactions.